Hi everybody, it's Mrs. Mancuso doing some Regents chemistry review, and I want to talk about concentration. So if I'm talking about concentration, I'm really thinking about how many particles per area. So I think about 2 glasses of lemonade. If one is really concentrated, I've got a lot of solute in my glass. And that is the kind of lemonade that you drink and you're like, ooh, wow, that is really like packing a punch. It's got a lot of particles. Maybe it's really sweet or really sour, but it's got a lot of particles in a small area. If something is dilute, that means you don't really have many particles. It's not concentrated. So to measure concentration, we can do a couple things. We can calculate molarity, or we can calculate parts per million. Molarity is a really common one. Parts per million is a little bit more rare. This is when you're looking for something that is like maybe it's toxic when it's in a very low concentration. So if you're looking at drinking water and you're like, oh, how much lead is in it? You're looking at parts per million. All right, so both of these are on our reference table. So we go over here to the back to concentration. Here's parts per million and here's molarity. So molarity is moles of solute per liter of solution. Moles of solute per liters of solution. So my first thing is make sure that you use liters if you're given milliliters. So if I have 100 milliliters and I have to put that into liters, I need to move it 1, 2, 3 decimal places. So I would have 0.1 liters. And let's say I have 4 moles. So you always want to make sure you do all your conversions. So obviously if I'm dividing 4 by 0.1, I'm going to get 40. It's a 40 molar solution. So that would be my answer. All right. And the next thing I want to talk about is what if you're not given moles? What if you're given grams? So you're going to actually have to do 2 steps because you can't punch grams into here. So instead, I go up here and I say, all right, I want to find out how many moles, and I'm given grams. So let's say I have something like CaCO3, calcium carbonate, and I have 150 grams. And I want to figure out how many moles that is. So moles is equal to grams over gram formula mass. So I'm given 150 grams, and now I got to figure out gram formula mass. So I need to look up calcium, carbon, and 3 oxygens. So oxygen, I know that's 16.0, so that's going to be 48. Carbon, I know, is 12.0, and calcium, I think, is just 40. So where I'm getting these numbers from is you go to your periodic table, and you go find the element, and you round to 1 place past the decimal. So I'm going to write 40.1. All right, so now I need to add these up. So 40.1 plus 12 plus 48 is equal to, oh, that is not right. 40.1 plus 12 plus 48 is equal to 100.1. That's the gram formula mass. So I'm going to put that under here, 100.1. All right, so then I take 150 divided by 100.1, and that would give me, all right, and let's talk about sig figs for a second. All right, if I'm given 150 grams, that's only 2 sig figs. That 0 on the end, I'm not confident that that was measured. So there's no decimal after it, so I only count the 1 and the 5 as sig figs. This has 1, 2, 3, 4 sig figs. So I can only use the one that has fewer sig figs to it. So I only want 2 sig figs in my answer. My answer was 1.498501498. This has a lot of sig figs. I can only use 2, so 1 point, and then I would have to round to my next sig fig, 1.5. So that's 1.5 moles. So when I'm calculating molarity, if I have 1.5 moles, and let's say I have 6.8 liters, then I want to do 1.5 divided by 6.8 equals. And again, this is 2 sig figs, this is 2 sig figs. So I'm going to round my answer 0.22 molar solution. So that would be my answer, 0.22. All right, and then parts per million. Parts per million, you want to take the grams of solute over the grams of solution, and then times it by 1 million. So let's say I have 0.05 grams, and I have 5,500 grams of solution, and then I got to go times a million. So I punch in 0.05 divided by 5,500 equals, and then times 1, 2, 3, 4, 5, 6 zeros equals. That is equal to, all right, so let's talk sig figs again. This only has 1 sig fig because that's a placeholder. This has 2 sig figs, so I want my answer to just have 1 sig fig. So that would be 9 parts per million would be my answer. All right, so that's how you calculate how concentrated something is. And if instead the question's asking, what's more concentrated? And it's asking you different things from table G. If you had to say, all right, at 10 degrees, what's the most concentrated? You go all the way up and see which one has the most particles in it. This has the most solute per water. So Ki would be the most concentrated, and the least concentrated would be down here at the bottom. If instead it was asking you about which one is most concentrated and 3 of them are soluble and 1 is insoluble, the one that would be least concentrated would be our insoluble one. All right, thanks for joining me.